Good evening, everyone. I'm Sathwika from CSC department. In this video, I'm going to give a presentation on errors and exceptional handling in Python. So coming to errors, there are two distinguishable kinds of errors. They are syntax errors and exceptions. Syntax errors are also known as parsing errors and are the most common kind of errors. Example, while true, print, Python programming. It raises a syntax error called invalid syntax. So the parser repeats the offending line and displays a little arrow pointing at the earliest point in the line where the error was detected. In the example, the error is detected at the function point since a colon is missing before it. So here, after a while, a colon should be placed, but since it is missing over here, a syntax error is raised in this example. Now in Python, exceptions, there are exceptional handling, try and except block, nested try block, and handling multiple exceptions in a single except block, raising exception, finally block, and user-defined exceptions. So let's try to understand what is an exception. When writing a program, we more often than not will encounter errors. And error caused by not following the proper structure syntax of the language is called syntax error or parsing error. Errors can also occur at runtime, and these are called as exceptions. And they occur, for example, when a file we try to open, it does not exist. Like file not found error and dividing a number by zero, it raises an zero division error. Whenever this type of runtime error occurs, Python creates an exception object. If not handled properly, it prints a traceback to that error along with some details about why that error has occurred. Now, moving on further, even if a statement or expression is syntactically correct, it may cause an error when an attempt is made to execute it. So errors that detected during this execution are termed as exceptions. So now let's consider an example like 10 into 1 divided by 0. It raises a zero division error because division by 0 is not possible. It raises an error. Now, zero division error, it has been raised, and the string printed as the exception type is the name of the built-in exception that has occurred. This is true for all built-in exceptions, but need not to be true for user-defined exceptions. So now let's try to execute this program. Well, let's assign a value for a equals 5 and then b equals 0. Then result equals 8 divided by b. Later we have to print C. Let's say this is C. So let's try to run. So this particular program raises a zero division error, that is division by 0. It's not possible. Now let's head back. Okay. Now, exceptional handling. How to handle this type of exceptions? To handle exceptions and to call code when an exception occurs, we can use a try or except statement. Now the try block, it contains code that might throw an exception. It's a possibility. And if that exception occurs, the code in the try block stops being executed. And if no error occurs, then the code in the except block does not execute. Only if the exception occurs, then the code in the except block gets executed. If no error occurs, then the except block, it does not execute. Now, if you have some suspicious code that might raise an exception, you can defend your program by placing the suspicious code in a try block. And after the try block, you can include an except statement followed by a block of code which handles the problem as elegantly as possible. Now, syntax of try, except, and else blocks are as follows. Now, try will perform our operations in that particular block, then except exception one. If there is exception one, then this block will get executed. And if there is exception two, then the exception two block gets executed. And else, if there is no exception, then else block gets executed. Now, there's a note that if a single try statement can have multiple except statements, this is useful when the try block contains statements that may throw different types of exceptions. Now you can also provide a generic except clause which handles any exception. After the except clauses, you can include an else clause so that the code in else block executes if the code in the try block does not raise an exception. The else block is a good place for code that does not need the try block's protection. Now this is a program to perform division and to understand the exceptional handling. So let's try to implement this program as well. Now what we are trying to do is we are basically trying to input a number. Let's say we have input of enter first number, and then D block, we have to input a second number of integer data type, enter second number, and let's try result equals A upon B. Then we have to print we have to print the result is equal to and then accept print zero exception handle print end of program end of the program. So let's try to run this program and let's try to input a number of say 1 and second number is 0. So the try block, the code that is generated in the try block, 1 divided by 0, it's impossible. So the code in the try block is wrong. So then it raises an error. So in order to handle the error or the exception that is raised during the event of the program, the code which is inside the except block gets executed. That is exception handled and end of program. Let's try to print let's say 0 division error. zero division error. So let's try to print over here. Let's print. Okay, so let's try to run the program. So enter first number as 20, next 10. So the result and the end of program is executed. Let's try to run again. 20 and 0. Now it's a zero division error. Now let's try to move on to the presentation. Okay. So next example for try and except. The try and except block, it is used to handle exceptions in Python. And whenever an exception occurs, it is caught by the except block, and the catch block cannot be used without the try block. So let's try to implement this program as well. And so if we now using the functions, we have to define the divide of number 1 and number 2. And let's try if result is equals to number 1 divided by number 2, then the remainder is equal to number 1 and except let's say except 0 division error, print you are dividing the divisor by 0. And next, else print your answer is false. It gives only the quotient is the result. And we have to print your answer is, which gives only reminder. This is nothing but result. I mean, just a reminder. And now next we have to input both the number 1 and 2. Input of enter the number 1 dividend value. Next, number two, int of input of enter the number two. This is divisor value, and then divide number one and number two. So let's try to run this program. Okay, now we can input a value called, let's say 128, and then divisor 14. So it gives us a quotient as 9.1428 and remainder as 2. So let's try to run this program again, and let's give the value as 120, second value as 0. So it gives output as you're dividing divisor by 0. So since division by 0 is not possible, the except block, it gets executed. And since dividing like dividing 128 by 14, it's possible. So there's no exception that is raised in this particular course, hence else block gets executed. So this is the difference between except and else. And yeah, so this is the output that has been generated onto the screen. And now let's try nested try block. So now we have to implement this, this both the codes in order to understand the concept of the nested try block. Let's try to do that. So let's try to generate the code. Okay, so let's first try to input a number. Enter the numerator value, and then let's say denominator is equals to int of input of enter the denominator value. Now next, let's try result is equal to numerator upon denominator. Then we have to print result is equal to and then next we have to accept, we have to generate the code in accept block. The print divide by 0 error. Next we have to generate another accept block, and here we have to print invalid input. Then next print end of program. So let's try to run this. let's input a value called 40 and 0. So this is the end of the program. And I mean, that's divide by 0 error. So first this except block gets first except block gets executed, and then second except block also gets executed. That's end of the program. And so let's try to run this program again. It's 40 versus 10. Now result is equal to 4. So now let's try to consider an example of another program. Let's say let's now let's input the value of a as enter first number, and let's try to input the value of b in order to enter the second number. Next we have to try that whether result is equal to a divided by b, then we have to print the result. Else except block print exception handled. Then we have to print error has occurred. Next we have to print the end of the program. Let's try to run this program now. Enter first number, say let's say plus 16, and then second number as 10. So result is 6 and the end of the program. Let's try to run the program again. Now 78 and 0. So the 0 division error has been occurred, and this is the end of the program. We have implemented these two programs in the terminal, and now let's try to implement this another program over here. And a try statement, it can have multiple different except blocks to handle different exceptions. So this is the example program in order to support this statement. Let's try to. So let's try to implement this program as well. Now let's import system and the try block. Number equals in of input of enter the numerator, and then denominator equals input of enter the denominator, and let's say result is equals numerator divided by denominator, and let's say print result is equal to the result, and accept zero, value error. Print invalid input, accept zero division error, print divide by zero error, and let's say print end of the program. So let's try to run this program. So let's try to enter the numerator as 30 and denominator as 10. So the result is displayed as 3 and end of the program. And let's try to run the program again. And now this time it's 38 and 0. So that is the divide by 0 error and end of the program. Now let's try to implement another program. Let's try to implement this program to demonstrate multiple except catch blocks. So the multiple exceptions can also be put into a single except block using the parentheses, and to have the except block in order to handle all of them. So let's try to demonstrate the multiple except block program. Here we have to try A is equal to input enter first number, and then B is equal to enter second number, and then A is equal. Okay, let's try to now let's try to input A as integer value, and then result is equal to A plus B. Then we have to print the result. Result is equal to and then except value error. We have to print the invalid input error, and then later except type error. Have to print type error, and except zero division error. We have to print divide by zero error, and let's try to print end of program. Now let's try to run the program. First number, let's say we have 70 and 0. So this is the type error and this is the end of the program. And let's try to run one more time. Let's say 80 and 10. So this is something, okay. So since we have declared over here the value, we have inputted a as an integer, but we have failed to input the value of b. The compiler, it raises an error whether the given input is of integer or float. So we didn't declare the data type of the, of the value like 10. Since it's the second number b, we have just inputted in the format of string. So since string and integer division is not possible, addition is not possible, so it raises an error. If we try to input, let's say b is int of b, and now we shall run the program stating 80 and then 10. So now the result, it's been printed as 90 and end of the program. So always remember, string and integer division is not, addition or any other operation is not possible. And since 80 divided by 10 is possible, it displays the result. And if the division, addition, like say a 70 and 0, and if we consider as b, the b value is not, I mean the b value is not declared whether it is an integer or a string or a float value or what type of value it holds initially. So since it is not declared here, this program, it raises an error. Addition of 70 and 0 is possible, but initially the value of b, it is not declared what type of the data type it holds, either an integers or a float value. So since we didn't declare earlier, the program raises an error. Now, if we try to run the program and if we try to input 70 and 0, now we are able to get the result. If we change the operation to division and let's say 45 and 0, so it is a 0 error. And let's try to run this program again and let's say 45 and 15. So the result is 3, and this particular operation, it doesn't raise any error, but before that we have given the second number as 0 and we have performed the division operation, it raises an error. So the code in except block gets executed. This is how we handle with multiple except blocks. And let's try to implement another code. And okay, so let's import the systems over here. And I try int of a. Okay, so let's remove this declaration for b, and let's say sum is equal to a plus b, and let's print the sum as. Now if we say we have declared a quotient of a true division, then later we have to print quotient is equal to. Now accept value error, and let's try to print this in a single format. So accept value error and type error. Print. Let's try to print invalid input error. And later accept like zero division error. It's already. We have to print divide by 0, and this is the end of the program. So let's try to run this. So let's enter first number as 38 and second number as 26. So this is an invalid input error, and so here let's make a slight change. Let's say b is equal to int of b, and now let's try to run the program. 38 and 19. So sum is 57 and quotient is 2, and this is the end of the program. And let's try some other operation. 28 and 0. So sum is 28, and since division is not possible, it raises a divide by 0 error, and this is the end of the program. So we have implemented this program. Now let's try to implement this second program. Okay, so let's try another way. Now we are defining divide numerator and denominator, and then result is equal to numerator upon denominator. We have to return result, and then later we have to try numerator is equal to int of input of, enter the numerator, and then denominator is equal to int of input of, enter the denominator, then result is equal to divide the numerator as well as the denominator, and then we have to print result. Then let's raise an exception of value error. There is print main block invalid input, and then accept zero division error. I have to print main block divide by zero error. And then let's try to end the program. Print end of program. Now let's try to run this. So numerator is 38 and denominator is 16. The result is here, and let's try 56 0. So divide by zero error. Now let's head back to the slide. Now raising an exceptions. Now we can raise exception in several ways by using the raise statement. And the general syntax for the raise statement, it is as follows: a raise, exception, argument, and trace back. Now let's consider this example: raise name error, hi there. So it has the name error like hi there. Now the sole argument to raise indicates that the exception to be raised. If an exception class is passed, then it will be implicitly instantiated by calling its constructor with no arguments. Now raise value error with the declaration of the shorthand for raise value error. So this is how to declare a raise value error in this format. Now this is an example program which illustrates the use of raising an exception. And let's try to implement this program. Before that, raising exception, it is similar to throwing exception in C++ and Java. So you can raise exception by using the raise statement. This is another program to raise an exception. So this is the program to raise an exception from except block. Let's try to implement all these programs which are related to raise the exception using the raise keyword. First of all, let's try to implement this function definition. The function name and then level, and if level is say less than 1, then raise exception of level, and okay, so this is the code below to this below the raise block, the code, I mean, which I'm going to execute the code immediately after the raise block. Then the code, it will not be executed if the exception is raised. So let's try to return the level. Okay. Now let's try another. Let's try L as a function name of -10, and let's try to print level L. Now we have to raise an exception using the except block. Except exception as E. We shall print that error in level argument E dot argument of 0. So let's try to run this program. So error in level argument as -10 is displayed onto the output screen. Now let's try to run another program. Try to print, let's enter the marks, and if marks equals into of input, and if marks are less than 0 or marks are greater than 100, for example, let's raise a value error over here and accept value error. Have to print that input out of range. So let's enter the marks, say 80. So that's it. If we enter the marks, say -10, it's input out of the range. So now let's try to have a look at another example. Define divide of numerator and denominator, and then you have to try the code whether the result is divisible. We have to return the result except zero division error. Zero division error, we have to print that divide function divide by zero error, and then we have to return 0. Now we have to try Just input the value for numerator. Int of input of enter numerator, and then denominators the same, enter denominator, and then the result is equal to then we have to print the result except value error, print main block invalid input, except zero division error, print main block divide by zero error, and then we have to print the end of program. Let's try to run this code. Enter numerator as 20 and let's say 5. So result is 4 on the end of the program. Let's enter say 49 or 98 and it's 0. So divide by 0 error and the end of the program. This is the divide by 0 error which has been raised over here. And now let's try to execute another program. So now let's try to raise an exception from except block. Earlier we have raised an exception without except block. Now we have to raise exception from an except block. And let's try. The result is equal to numerator upon denominator. And then we have to return the result. Now accept the zero division error. Let's print divide by 0. That is the divide function. And then we have to raise an exception. Then further, we have to try to input the values input of enter numerator. Okay. Now next denominator is equal to int of input of enter denominator, and then the result is equal to divide numerator as well as the denominator. Then later on we have to print the result except value error. Print that main block invalid input and accept zero division error. Print main block divide by zero error. All right, let's print this as end of the program. Now let's try to run this program. 57 and then let's say it says 19. Result is 3, that's the end of the program. Let's say 78 or 79 0. So there's a runtime error of the race. Now let's head back to the program. Now coming to exception chaining. Exception chaining, it happens automatically when an exception is raised inside an except or finally section. So exception chaining can be disabled by using from none idiom. So try open database of some database.sqlite which accept IO error, that is input output error. We have to raise runtime error from none. So this exception changing it is disabled by using none keyword. And now coming to finally, it is used to ensure some code runs no matter what error occurs. You can use a finally statement. The finally statement is placed at the bottom of a try or except statement. So the code within a finally statement always runs after execution of the code in the try and possibly in the except blocks. And so this is a program to demonstrate finally blocks. Let's try to implement that. Now let's program to demonstrate finally. So let's try to input a value of a into of input of enter. So first number, then v into of input, enter the second number, and now let's print the result is equal to a divided by b, and we have to print the result as Now later we have to raise an exception, except of value error and the type error. We have to print invalid input error and except zero division error. We have to print divide by zero error. And then finally, we have to print this code will run no matter what. Then we have to print end of program. So let's try to execute. Enter first number as 48 and second 0. So the code has raised an error, but at the same time, the finally block got implemented that this code will run no matter what. And if we try to execute, so even though if the input is, the exception has occurred or the exception it has not occurred, the try block gets executed. So next, now the code in a finally statement runs even if an uncaught exception occurs in one of the preceding blocks. So that's it. And this is the code to use finally block. Try and finally example has been provided over here that we can use a finally block along with a try block, that the finally block is a place to put any code that must execute at any cost. Will the try block it raise an exception or not? So before going to use the defined exceptions, let's try to look at these two examples over here. And then let's head over here. Let's first we have to try. We have tried to print 1, and then let's print 10 divided by 0. And okay, so now let's raise an error in except block, that is except 0 division error, print unknown underscore variable, and then finally print this is executed last. This is executed last. Executed last. So let's try to run. Division of So it has taken one, that is division not possible, and this is executed last. Since division by 0 is not possible, it raises an exception. This is executed last. It prints no matter whether the code has an exception or not. And let's try to print. So let's try to execute this example as well, where we have assigned two values a and b, where a is equal to int of input of enter a value. Okay. And then b is equal to int of input of enter p value. So now let's print c as a by b. Now let's raise an error. Okay, let's take some division. Except a zero division error. We have to print division can't be possible since p is equal to 0. And then later, let's take an else block to handle this. Print AB value, that is C. Now, let's try to implement finally. Have to print enter of program. Try to print, let's enter the A value as 10 and 0. So division can't be possible. And later, let's try to run, enter A as 10 and 2. So it's 5. So here, finally has executed, even though the exception has occurred. It has, even the exception has occurred in that case, like the first case where exception has occurred, and it has also executed in the second case where the exception it has not occurred. So it executes in both the cases. And so coming to user defined exceptions, the Python, it also allows us to create our own exceptions by deriving classes from the standard built-in exceptions. For example, let's consider this class error exception pass and the class input error. The error is, and here exception has been raised that for errors in the input, the attributes, the expression, that input expression in which the error has occurred, and also the message has been declared as the explanation of the error. And now we are defining this init self expression of message, where self expression, and then we are declaring self for the message also. And next we have declared another class of transition error. It is raised when an operation attempts a state transition that's not allowed. And here attributes are previous, that state at the beginning of the transition, and the next attempted the new state. The message is explanation of why the specific transition is not allowed. And def in itself previous, next, and message. We are declaring a previous, next, and message using self as an argument. And then the most of exceptions are defined with the names that end in error, similar to the naming of the standard exceptions. Many standard modules define their own exceptions to report errors that may occur in functions they define. So more information on classes is present in chapter of classes. And then now defining the cleanup actions. The try statement, it has another optional clause which is intended to define cleanup actions that must be executed under all the circumstances. For example, try raise keyboard interrupt, finally print goodbye world. Now, goodbye world and keyboard interrupt, it has been raised. So let's try to implement this, which is try raise keyboard interrupt. Interrupt. Then next, finally, and print goodbye world. So, so here we have raised a keyboard interrupt, which raises an exception. Now, if a finally clause is present, the finally clause will execute as the last task before the try statement completes. Now, the finally clause, it runs whether or not the try statement produces an exception. And the finally clause is executed in any event. In real world applications, the finally clause is useful for releasing external resources such as files or network connections, regardless of whether the use of the resource was successful or not. And so now let's try to implement this program to understand this concept. So this is another program of user defined exceptions. Let's try to implement this program where we are defining the division as x and y. And later on we have to try result is equal to x by y, except 0 division error, print division by 0. And later else print result. Now finally print executing finally clause. So let's try to run. divide of, let's say, 2 comma 1. Let's say divide of 2 comma 0. Here now the result is 2, and executing the final clause for the first case. And for 2 comma 0, division by 0 error, here error occurs, 0 division error occurs. So even in this case also the finally clause gets executed. So in order to support the statement finally clause, it gets executed in both the cases, whether an exception occurs or an exception does not occur. It stays true all the time, throughout the program. So now let's try to execute the user-defined exception. Now we have to define a class of, say, invalid range and of exception. So next, we have to pass the statement. Now we have to try that marks. Just input and enter the marks. Now we should enter that marks equals of marks, and then if the marks are less than 0 or the marks are greater than 100. All right, if the marks are greater than 100, so let's raise an invalid range error, and now we have to, if an error doesn't occur, then we have to print the marks of marks, and then except value error, print invalid input, now accept invalid range, print input value out of range. Let's try to run this program. Let's say enter the marks of minus 78, so input value out of the range. Let's enter marks of 98, so the marks 98 are displayed onto the screen. And now predefining the cleanup actions, or predefined cleanup actions, like some objects that define standard cleanup actions that to be undertaken whether the object is no longer needed, and regardless of whether or not the operation using the object succeeded or failed. So let's consider, for example, for line in open myfile.txt, print line n equals the end of the program. That is, when we some objects that define the standard cleanup actions, and when this object that is no longer needed, regardless of whether the operation it using the object it has succeeded, or whether the error has occurred using the operation with the object. So the standard cleanup actions are predefined initially, So the problem with this code is that it leaves the file open for an indeterminate amount of time after this part of the code has finished executing. This is not an issue in simple scripts, but can be a problem for larger applications. And the with statement, it allows objects like files to be used in a way that ensures that they are always cleaned up promptly and correctly. So with open myfile.text as f for line in f, print the line. So what this with statement is basically does is, suppose we have declared an object initially for myfile.text. We don't know whether the file is present in our hard disk or not. Just we have declared and we have done few operations. So even though the operation with an object it has success or failed, no, that's not the case here. And sometimes the code we have generated, it leaves the file open and for some span of time, and even though after the code has finished executing, this file still remains open. So in order to handle this kind of errors, we use a which statement which ensures that the file is closed properly and it cleans up and it prompts correctly. So it is used for this predefined cleanup actions in order to ensure the file is closed correctly. And so objects like files, they provide a predefined cleanup actions which it will indicate this in the documentation. So uh, some objects like, let's consider files, for example, files or folders, they provide some predefined cleanup actions. I mean, which are defined which are defined initially in order to indicate so that particular document or file is closed correctly without raising any kind of errors. I mean, uh, without creating any disturbances. Like, it is not an issue with some simple script, but when it comes to larger applications, then it may cause some serious problem. So that the file remains unclosed, and it also depends on the code. Like, if we have just generated, we have let's consider, for example, we have created a random code and the code has executed for some extent, but the file which we have initially opened the file, and the file is not closed, it's not closed completely. So this may cause and some issues. So in order to get rid of the issues, we use a with statement. It ensures the file to be closed, and in order to clean up the promptly, and it is used in predefined cleanup actions. So in some objects like files and folders, this with statement is used as a predefined cleanup. It is indicated in the documentation. So thank you. That's the end of the presentation.